This activity is entitled square root spiral. The objective of this activity is to construct the square root spiral. Let's see the concept in hand first. When you have to plot square root of 2 on a number line, then you just draw the number line, take 0 on it and take 1 on it. That's all we require. This 0 to 1 is 1 unit. Now we draw a perpendicular line on 1 like this, and we take this part as 1 unit again. If this part is 1 unit and it is perpendicular to the original 1 unit which we have taken on the number line, then the hypotenuse of this triangle, that is this line OP, gives the length of square root of 2. You can actually represent that on a number line using a compass, but we are intending to find what happens when we follow this procedure further. Now with OP, we need to make another angle of 90 degree like this. So this angle is 90 now, and this line, the length is again 1 unit. So if you join this point Q with O, OQ will be equivalent to square root of 3. And likewise, you can go on and on. Take another perpendicular of length 1 unit. This is R, and then you join it with O, you get square root of 4, and that is 2. So you will find that OR is exactly 2 units. You go on and on like this, keep on making 1 unit perpendiculars, you will get the next irrational number, that is square root of 5, and so on. So what happens when we make a number of such triangles? We will obtain a spiral. As you can see, I'm constructing some of them by taking 1 unit. This process goes on and we get a spiral like this, and this is what we call a square root spiral. To perform this activity, we need white drawing sheet, sketch pens, and traditional instruments, that is geometrical instruments. The activity is very useful, and we will come to know how these irrational numbers are represented on the number line. Let's see how this activity is performed.
So to construct a square root spiral, we have first taken a ray starting from O, and we have marked a point A1 on this ray such that this length OA1 is 1 inches. I have taken 1 inches because that distance will be appropriate to construct the square root spiral. After that, at point A1, we have made a 90 degree angle with the ray, and the length of this line segment is also 1 inches, and therefore we obtain this point A2. Now we have a right angle triangle wherein the base is 1 unit and the perpendicular is also 1 unit. If you join this line, that is the hypotenuse, and apply Pythagoras theorem in OA1A2, you will obtain OA2 as square root of 2. So that gives the length or the value of square root of 2. Now we repeat the same process by constructing a perpendicular on OA2, that is the hypotenuse of the first triangle. So you can see this A2, A3 again is 1 inches, and therefore we obtain another right angle triangle OA2, A3, in which the base now is root 2 and the perpendicular is 1. So if you join this, the hypotenuse, and apply Pythagoras theorem in OA2, A3, you will obtain the length of OA3 as root 3. You can repeat this process and get the value of root 4 by constructing another 90-degree angle, and then root 5, root 6, root 7, root 8, root 9, root 10, root 11 and so on. This figure so obtained is called a square root spiral, and that completes our activity.